And we're back. This vlog's tracking in regards to some of the other power conditioning devices I have in the house, as I mentioned earlier. Behind here, this multimeter is a Tripp Lite 1800 AVR power conditioner. The purpose of this device is to regulate and provide the cleanest power or voltage to the connected device. This piece of hardware ensures whatever is connected gets clean power, well regulated voltage that is clean and filtered as possible. The outcome, you have electronics that are going to last longer, that will not suffer dirty power. If you live in an area where there's high variability, whether it be brownouts or high voltages, this single device and similar will provide you a lifetime of enjoyment to whatever is connected. So that's one of the things I want to address in regards to some of the redundancy, some of the failovers, some of the actual hardware I have deployed in various parts of the house. Not everybody can afford to install some of the very large UPSs that I've shown previously, but these other smaller models of power conditioners or AVRs, such as from Tripp Lite, are easily purchased secondhand, used, what have you, even new at reasonable prices. So Tripp Lite offers several models. I believe the smallest model is 600 watts. Then it goes to 1200, 1800, and I want to say it's 2000 or 2500. So right now, as I had set up previously, I have this variac, and it allows me to vary the voltage from 0 all the way up to 147 volts AC. The multimeter here to the right, the Fluke, is connected to the variac, which shows right here. Okay, so it's measuring what the line power or voltage is being supplied to this Tripp Lite, this big black brick in the back. Okay, this multimeter to the left is measuring what it's provided to the connected device. So in this case, we just have a multimeter. So we have 120 volts AC going in, and we get approximately 120 volts coming out. Okay, we have green showing it's in a normal good state, and there's no buck or boost of the voltage. So let's see what happens and when it starts cutting in and how it compensates over here. Okay, right there. So at 130 volts, you see it kicked in. It's basically bucked the voltage. Right now, over here, it's 116 volts, but the input is 130. And I believe the orange means it's medium. Now it's in red, meaning it's extremely high voltage. And again, here you can see it's dropped the voltage from a massive 140 to 125, well within the safe working limit of any electronics. And we'll just crank it all the way up, see what happens. So the maximum that this variac can provide is 144, 145 volts AC. And right here, it's basically cut it off at 129, well within a working operating limit of any electronics. And approximately 137 goes down to medium. At 126, went back into the green. Output's 126 and mirrors it. Now we're going in the opposite direction. Now the system is boosting, because we're at 114 volts. and went back up to 123. We're at 110. The output is 119. And it's bucked again. So we're at 104. The output's 122. So it looks like $80. So it looks like the safe operating range is approximately 92 volts. The lowest it can go, still maintaining at 110. Now, depending on electronics, some obviously can take below about 90 volts. When you're getting down to the 80 volts input, the magic smoke's going to be let out of the box. So I would not encourage anybody to go to that low level. I wasn't going to drop this down to 0 because that's essentially, again, this is not a UPS. This is basically a line conditioner, which helps regulate to provide a steady voltage to the connected device. So let's put it back in there. Let's make her happy. Let's back into the medium or orange. And back in the green. We'll set at 120. So at 120, the output is fairly consistent at 120. So this is just a quick demonstration and illustration of some of the hardware I have in place for electronics that I've connected throughout the house, which does not require a UPS system. But I do want to ensure whatever's connected has clean, reliable, highly regulated voltage or power to the device, which obviously extends the operating service life of whatever is connected. So it's something for people to consider. I've been using Tripp Lite for more than 25 years with great results. They're a great company, same as APC and many others. But I have first-time experience with this particular device because I have, I think, 9 of these devices now, from their 600 watt, the 1200, several 1800 watts, and I have a single, I think it's a 2000 2500 watt one, which powers some really heavy duty gear. But regardless, this thing is worth every penny. I've been fortunate enough to get them on sale or what they call NOS, new old stock, or used. Get one. Well worth it. Protect your electronics. All right, till next time.